space does not just challenge the human body, it slowly breaks it at the smallest level. Deep inside your cells, something invisible can strike without warning. It passes through skin, through bone, through organs. It leaves damage that cannot be felt in the moment. And once it starts, it does not simply stop. Astronauts are exposed to a force that can damage DNA instantly. Not heat, not pressure, not lack of oxygen. The real danger is something far more silent. Radiation that you cannot see. Radiation that you cannot block completely. Radiation that follows you everywhere in space. Most people think the greatest threat in space is running out of air. That is not true. The most dangerous threat is something you cannot escape, even inside advanced spacecraft. Even with the best technology ever built, humans are still vulnerable. That is the part that makes this so unsettling. Right now, space agencies are preparing for the next giant leap. Missions are being planned that will take humans farther than ever before. Not just short trips, not just days in orbit. These are long journeys, months, even years. The goal is clear: humans on Mars, humans deeper into space than any generation before. This sounds like progress. It sounds like the future unfolding. But behind that ambition is a problem that has not been solved: cosmic radiation. It is one of the biggest unknowns in human space travel, and it is one of the most dangerous. On Earth, people are protected. The planet has a thick atmosphere. It has a powerful magnetic field. Together, they act like a shield. They block and deflect most of the harmful radiation coming from space. That is why life can exist here. But once astronauts leave Earth, that protection disappears. In orbit, protection is already weaker. On the way to Mars, it is almost gone. That means astronauts are exposed to a constant stream of high-energy particles. These particles move close to the speed of light. They come from the sun. They come from distant stars. Some have traveled across the galaxy before reaching the human body. And when they hit, they do not just bounce off. They pass straight through. They collide with atoms inside the body. They break chemical bonds. They damage DNA. And this damage begins instantly, not after days, not after weeks. The moment exposure happens, the process begins. That is the part most people never hear about. Space exploration is often shown as heroic. It is shown as inspiring. People see astronauts floating, smiling, looking down at Earth. That is only part of the story. The hidden reality is far more disturbing. Inside the body of an astronaut, cells are being altered. Some of them die, some of them mutate, some of them continue to function, but not correctly. Over time, this damage builds. It does not go away. Even worse, the body does not always repair it properly. Small errors begin to stack up. One damaged cell becomes many. One mutation becomes a chain reaction. Years later, the consequences can appear. Cancer, brain damage, changes in behavior, loss of memory, increased risk of serious disease. And here is what makes this even more unsettling. There is no perfect shield against it. Engineers have tried to design better protection, thicker walls, new materials, advanced technology. But cosmic radiation is extremely powerful. Some particles can pass through spacecraft as if it is not even there. That means astronauts carry this risk with them at all times. Every second in deep space adds to the exposure. Every mission pushes the limits further. For short missions, the risk is lower. For long missions, it becomes much more serious. And for a mission to Mars, the danger reaches a completely different level. A journey to Mars could take months just to arrive, then more time on the surface, then months to return. That is a long period of continuous exposure. During that time, astronauts are not just exploring space. They are slowly absorbing damage that cannot be undone. And scientists still do not fully understand the long-term effects. There are studies, there are experiments, there is data from past missions. But deep space is different. The radiation environment is harsher. The exposure is longer. The risks are higher. This is why many experts consider cosmic radiation the biggest barrier to human exploration beyond Earth. Not fuel, not distance, not technology. The human body itself, that is the limit. And yet, humanity is moving forward anyway. Plans are being made. Missions are being designed. Astronauts are training for journeys that will expose them to conditions no human has ever experienced for that long. All of this raises a critical question. What actually happens inside the human body when cosmic radiation hits? What does it do to the brain? How does it change cells over time? Why do some astronauts report strange experiences that scientists still struggle to explain? And how dangerous is it really for future missions to Mars and beyond? In this video, you will learn the hidden effects of cosmic radiation on the human body, the damage it causes at the cellular level, the disturbing changes it can create in the brain, the long-term risks that may not appear until years later, and why this invisible threat could shape the future of space exploration more than any other factor. Some of these facts are rarely discussed. Some are still being studied, and some may change how you see space travel completely. Stay with this video until the end, because the deeper you go into this topic, the more unsettling it becomes. Welcome to the channel. If you want to understand the universe in a deeper and more honest way, make sure you subscribe and stay connected. Cosmic radiation sounds simple, but it is not like anything experienced on Earth. It is not the kind of radiation from medical scans or everyday sources. It is made of tiny particles moving at extreme speeds. These particles carry enormous energy. Some travel close to the speed of light. When they hit something, they do not stop easily. At its core, cosmic radiation is a stream of high-energy particles coming from space. Most of them are protons. Some are heavier atomic nuclei. These include elements like iron that have been stripped down to their core. Without electrons, they become highly charged and incredibly aggressive as they move through space. These particles are not random. They come from powerful events across the universe. The sun is one major source. It releases bursts of radiation during solar storms. These events are called solar particle events. They can send waves of energetic particles across space in a short time, but the sun is only part of the story. Far beyond the solar system, much more violent sources exist. When massive stars explode in supernova blasts, they release huge amounts of energy. These explosions accelerate particles to extreme speeds. Some of those particles travel for millions of years before reaching our region of space. These are called galactic cosmic rays. They are among the most dangerous forms of radiation known. They carry far more energy than radiation produced on Earth. And because of that, they are much harder to stop. On Earth, people are protected from most of this danger. The planet has a thick atmosphere. It acts like a shield. When cosmic radiation enters, it collides with air molecules and loses energy before reaching the ground. At the same time, Earth has a magnetic field. This field deflects many charged particles away from the surface. Together, these layers form a powerful barrier. In space, that barrier is gone. There is no atmosphere to absorb incoming radiation. There is no strong magnetic field to push particles away. That means astronauts are exposed directly. The particles travel through spacecraft walls with far less resistance than expected. Some pass straight through metal. Some create secondary radiation when they hit the spacecraft. This can make the situation even worse. One incoming particle can trigger a chain of smaller particles inside the structure. That increases the total exposure inside. Astronauts face different types of radiation at the same time. Solar particle events are sudden and intense. They can deliver high doses in a short period. Galactic cosmic rays are constant. They are always present. They slowly build exposure over time. This combination makes space extremely dangerous. The most unsettling part is how deeply these particles can penetrate. This is not surface-level exposure. These particles can pass through skin, through organs, and even through the brain. Some go completely through the body in a straight line. As they move, they leave a trail of damage behind. This is why cosmic radiation is not considered normal radiation. It behaves differently. It carries more energy. It travels farther. And it interacts with the human body in ways that are still not fully understood. And once these particles begin passing through living tissue, the real damage starts to unfold at a level that cannot be seen. When cosmic radiation enters the human body, it does not stop at the surface. It moves straight through. Skin offers almost no resistance. Muscle does not slow it down much. Even bone cannot fully block it. These particles travel in clean, invisible paths, cutting through living tissue. As they pass through, they collide with atoms inside cells. These collisions are violent at a microscopic level. Electrons are knocked out of place. Chemical bonds are broken instantly. Molecules that once worked perfectly begin to fall apart. The most critical target is DNA. DNA carries the instructions for every function in the body. It controls how cells grow, repair, and communicate. When radiation hits DNA, it can break the strands apart. Sometimes it damages only one side. Sometimes it snaps both strands at once. This is called a double-strand break. It is one of the most dangerous types of damage a cell can face. This damage begins the moment radiation passes through. There is no delay. There is no warning. The cell tries to respond. It activates repair systems that search for the broken pieces. In many cases, the cell succeeds. It reconnects the strands and continues to function. But the process is not perfect. Small mistakes can happen. A single error in DNA may not seem important. But over time, these errors begin to accumulate. One damaged cell becomes two. Two become many. Each carries small changes that were not there before. Some cells respond by shutting down completely. They stop dividing. They die. This might sound like a good outcome, but it can weaken tissues if too many cells are lost. Other cells survive, but they change. They may begin to divide in an uncontrolled way. They may ignore signals from the body. This is how cancer can begin, from a few damaged cells that no longer follow the rules. There is another layer to this damage that is less known. Radiation does not only hit DNA directly, it also interacts with water inside the body. The human body is made mostly of water. When radiation passes through, it can split water molecules apart. This process creates highly reactive particles called free radicals. These free radicals are unstable. They search for other molecules to react with. When they find them, they cause more damage. They attack DNA, proteins, and cell membranes. This creates a chain reaction inside the cell. One particle of radiation can trigger multiple points of damage. This makes the overall effect much more complex. The body continues trying to repair everything. It works constantly correcting damage, removing broken cells, and maintaining balance. But in space, exposure does not stop. New damage keeps happening. The repair system never gets a full break. Over time, the balance shifts. Repair becomes less effective. Errors become more common. Cells begin to function differently. Some become weaker. Some become unstable. The most unsettling part is that none of this can be felt in the moment. There is no immediate pain, no clear signal that something is wrong. An astronaut can feel completely normal while this process is happening deep inside the body. Days pass, weeks pass, even months. All the while, damage is building quietly at the molecular level, preparing the conditions for effects that may only become visible much later, including changes that reach one of the most sensitive and complex organs in the human body. As radiation continues to pass through the body, some of the most serious effects begin inside the brain. This is where the damage becomes more complex and more disturbing. The brain is not just another organ. It controls thought, memory, emotion, and decision-making. Even small changes can have deep consequences. When high-energy particles move through brain tissue, they do not simply pass without effect. They disrupt the structure of neurons. These are the cells responsible for carrying signals. They form networks that allow the brain to function smoothly. Radiation can break connections between these cells. It can alter how signals travel from one part of the brain to another. This changes how the brain processes information. In controlled studies, scientists have observed clear effects. Animals exposed to space-like radiation show reduced learning ability. They struggle with memory tasks. They take longer to respond. Their decision-making becomes less reliable. These are not minor changes. They point to deeper alterations in how the brain operates. The same concern exists for humans. Astronauts on long missions may experience subtle cognitive decline. This can include slower thinking, difficulty focusing, and reduced problem-solving ability. In space, where every decision matters, even a small delay or mistake can become critical. There is also evidence that radiation affects mood and behavior. The brain relies on chemical signals to regulate emotions. Radiation can disrupt these signals. It can change how certain brain regions interact. This may increase the risk of anxiety and depression. It may also lead to changes in behavior that are difficult to predict. These effects are not always immediate. They can develop slowly. Over time, as more radiation exposure builds, the changes may become more noticeable. A person may begin to think differently, react differently, feel differently, and they may not fully realize it is happening. One lesser-known effect involves inflammation in the brain. Radiation can trigger the immune response inside brain tissue. This leads to swelling at a microscopic level. Chronic inflammation can damage neurons over time. It can interfere with normal brain activity. This process is often linked to serious neurological conditions on Earth. Some scientists believe prolonged exposure to cosmic radiation could increase the risk of brain degeneration. The pattern seen in studies shows similarities to diseases that affect memory and cognition. While research is still ongoing, the possibility is taken very seriously. Another disturbing detail is how persistent the damage can be. Unlike some tissues in the body, the brain has limited ability to repair itself. Once certain neural connections are lost, they may not fully recover. This means some effects could last long after a mission ends. Even more concerning, radiation can affect the hippocampus. This is the part of the brain linked to memory formation. Damage here can lead to long-term memory issues. It can also impact the ability to learn new information. This creates a situation where an astronaut may return physically stable, but with subtle changes in how their mind functions. The idea that space can reshape the brain at a fundamental level adds a new layer of risk to exploration. It is no longer just about surviving the journey. It is about preserving the mind during that journey. And as these changes continue to develop, they connect directly to another long-term danger that may remain hidden for years before it fully reveals itself. As the damage inside cells continues to build, one of the most serious risks begins to take shape. It does not appear immediately. It develops slowly, often without any clear signs. Deep inside the body, altered DNA starts to change how certain cells behave. When radiation breaks and rearranges DNA, it can activate harmful processes. Some genes that normally control cell growth stop working properly. Other genes may become overactive. This imbalance can push cells into uncontrolled growth. This is how cancer can begin. In space, this risk becomes much higher. Cosmic radiation is not like the low-level exposure people receive on Earth. It is stronger, deeper, and more damaging. Each particle can leave a trail of destruction across multiple cells. Over time, these small events begin to add up. Radiation exposure in space is cumulative. This means every moment counts. Each hour adds to the total dose. There is no clear, safe limit once outside Earth's protection. Even low levels, if sustained over long periods, can increase the chance of serious disease. For astronauts on short missions, the risk is controlled. For long missions, especially those lasting months or years, the exposure becomes much more concerning. The body keeps collecting damage, and the repair systems begin to fall behind. Another unsettling detail is the type of cancers linked to this kind of radiation. Studies suggest a higher chance of rare and aggressive forms. These are not always the common types seen on Earth. Some may grow faster. Some may be harder to detect early. This makes them more dangerous over time. The pattern of damage caused by high-energy particles is also different. Instead of affecting a small area, these particles can pass through multiple tissues in a straight line. This increases the chance of mutations in different parts of the body at once. This creates complex risks that are difficult to predict. One of the most troubling aspects is the delay. Cancer caused by radiation does not usually appear right away. It can take years, sometimes decades. An astronaut may complete a mission, return home, and feel completely healthy. Life may continue as normal. Then, much later, symptoms begin to appear. By that time, the original exposure is far in the past. The connection is not always obvious, but the damage that started in space continues to develop quietly inside the body. This delayed effect makes the risk harder to manage. Doctors can monitor astronauts after missions. They can run tests and track changes, but they cannot erase the exposure that already happened. Once DNA has been altered, the process cannot simply be reversed. There is also uncertainty in how different individuals respond. Some people may repair damage more effectively. Others may be more vulnerable. Genetics, age, and overall health all play a role. This adds another layer of unpredictability to long-term missions. Astronauts are aware of these risks. They train for years. They prepare for extreme conditions. But this is one danger that cannot be fully controlled. It is accepted as part of the mission. The idea that a journey into space can leave effects that surface decades later changes how these missions are viewed. It shifts the focus from immediate survival to lifelong consequences. And beyond cancer, there are other strange and lesser-known effects that begin to appear during missions, some of which are experienced in real time and still not fully understood by science. Not all effects of cosmic radiation stay hidden for years. Some appear during the mission itself. They are strange, unexpected, and difficult to explain at first. Astronauts have reported seeing flashes of light in complete darkness. Their eyes are closed. The cabin is dim, yet sudden streaks or bursts appear in their vision. These flashes are not coming from outside. They are happening inside the eye. High-energy particles pass through the retina. As they move through, they trigger signals in the visual system. The brain interprets these signals as light. This creates brief flashes, lines, or even shapes. Some astronauts describe them as streaks moving across their field of view. Others report small bursts that appear and vanish instantly. This phenomenon has been confirmed in multiple missions. It shows that radiation is not just surrounding the body. It is passing directly through sensitive organs in real time. The brain is reacting to events that cannot be seen or stopped. Beyond the eyes, other systems begin to show signs of stress. The cardiovascular system is one area of concern. Blood vessels are lined with delicate cells that help regulate flow and pressure. Radiation can damage these cells. Over time, this may lead to stiffening of the vessels. It may also increase the risk of heart disease. Some studies suggest that prolonged exposure could affect how blood circulates. Small changes at the cellular level may grow into larger problems later. This risk is still being studied, but early results are enough to raise concern among scientists. The immune system also begins to weaken. This system protects the body from infection and helps repair damage. Radiation can reduce the number of certain immune cells. It can also affect how these cells respond to threats. As a result, the body may become slower at fighting infections. Wounds may take longer to heal. Even minor injuries could become more serious if the body cannot respond quickly. In space, where medical resources are limited, this becomes a serious issue. There are also questions about reproductive health. Radiation can affect reproductive cells. In men, it may damage sperm. In women, it may impact egg cells. These cells are highly sensitive to DNA damage. Changes here could have long-term consequences. One concern is the possibility of passing mutations to future generations. If reproductive cells are altered, those changes could be carried forward. This adds a new layer of risk that extends beyond the astronaut. Another lesser-known detail involves how radiation interacts with different parts of the body at the same time. A single particle can travel through multiple organs in one path. It may pass through the brain, the heart, and other tissues in a fraction of a second. This creates a pattern of damage that is complex and difficult to predict. Scientists are still trying to understand the full impact of these events. Some effects are clear. Others remain uncertain. There are gaps in knowledge, especially when it comes to long-duration exposure in deep space. This uncertainty is what makes the situation more unsettling. Even with advanced research, not every outcome can be predicted. New effects may appear as missions become longer and more ambitious. And as humans prepare to travel farther than ever before, these unknowns become even more critical, especially when exposure is no longer measured in days, but in months and years far from Earth. A mission to Mars changes everything about radiation risk. It is not just a longer trip. It is a completely different level of exposure. Every extra day in deep space adds more damage to the human body. There is no pause. There is no safe zone. The radiation never stops. Traveling to Mars takes months. Not days, not weeks, months of constant exposure to cosmic radiation. During this time, astronauts are far beyond Earth's protective shield. They are fully inside an environment filled with high-energy particles moving in every direction. On Earth, the magnetic field protects life. It pushes away charged particles from space. It acts like an invisible barrier around the planet. Without it, life as we know it would struggle to exist. Mars does not have that protection. It once had a weak magnetic field in the distant past, but it disappeared long ago. Today, Mars has almost no global magnetic shield. Only small, scattered magnetic areas exist in certain regions. They are not strong enough to protect a human body across the planet. This means astronauts on the surface of Mars would still be exposed to radiation. They would not just face danger during travel. The danger would continue after arrival. Another major problem is spacecraft shielding. Spacecraft are designed with protective materials, but there is a limit to how much protection can be added. Too much shielding adds weight. More weight requires more fuel. More fuel increases cost and complexity. This creates a balance between safety and practicality. Even the best designs cannot block everything. High-energy particles can still pass through walls. Some particles are so powerful that they create secondary radiation after hitting the spacecraft structure. This means the inside of the spacecraft can still become a source of radiation. Astronauts are never fully isolated from exposure. One of the most dangerous situations in space travel comes from solar storms. These are sudden bursts of energy from the sun. During a strong solar event, radiation levels can rise rapidly. In deep space, there is little warning and almost no protection. A powerful solar storm can deliver a high dose of radiation in just hours. This is one of the most serious risks for a Mars mission. Astronauts could be traveling or even resting when a solar event occurs. Without quick shelter inside heavily shielded areas, exposure could become dangerous very fast. Some studies suggest that certain solar storms could reach harmful levels in a short time window. Unlike Earth, there is nowhere to hide. Mars offers no magnetic protection. Spacecraft offer only partial shielding. And the journey itself leaves astronauts exposed for months at a time. This combination makes Mars missions one of the most extreme environments humans have ever attempted to survive. Even small increases in exposure time can change everything. A few extra weeks in space can add significantly to the total radiation dose. Over a full mission, this builds into levels that approach the limits of what the human body can safely tolerate. Every system in the body is affected. Every cell carries the risk of damage. And yet, plans continue to move forward. Missions are being designed. Timelines are being set. Technology is being developed to push humans farther into space than ever before. But each step forward also increases the pressure on one critical factor that cannot be redesigned easily. The human body itself, still operating under the same biological limits, now being pushed farther than it was ever meant to go. Cosmic radiation is not just another challenge in space. It is one of the biggest barriers standing between humans and deep space travel. It is invisible, it is constant, and it works silently at the level of cells, DNA, and the brain. Unlike other dangers in space, this one does not announce itself. There is no sound, no warning, no immediate pain in most cases. The damage builds quietly over time, one particle at a time, one cell at a time, one small change after another. The unsettling truth is that space exploration is not only about technology and engineering, it is also about biology. The human body was never designed for this environment. Every mission beyond Earth pushes it into conditions it cannot fully adapt to. Even with advanced spacecraft and careful planning, full protection is still not possible. Some radiation will always get through. That means every journey carries a hidden cost, a cost that may not be visible during the mission itself, but may appear years later in ways that are difficult to predict. Scientists continue to study this problem. New materials are being tested. New shielding methods are being developed. But the solution is not complete, not yet. The universe outside Earth remains far more extreme than anything found on our planet, and still humanity continues to move forward. Plans for Mars missions are growing stronger. Space agencies are preparing for longer journeys, deeper exploration, and bigger goals. The desire to reach other worlds is powerful enough to push through even the most serious risks. This creates a difficult balance. The dream of exploring the universe is inspiring, but it comes with consequences that are not fully understood. The further humans travel, the more they step into an environment that slowly reshapes the body in ways science is still trying to understand. Cosmic radiation is part of that hidden story. It is not dramatic in the way explosions or collisions are. It is quiet, persistent, invisible. And it may be one of the most important limits that determines how far humanity can truly go. The question is no longer just about reaching Mars or beyond. It is about what those journeys do to us along the way and what we are willing to accept in exchange for discovery. The universe is waiting, but it does not come without cost. If you want to explore more deep science stories like this, make sure to like the video and subscribe to the channel. There is much more about the universe that is still waiting to be uncovered.